Hello. In this video, I'm going to show the transformation applied to the parent function f of x equal x squared. This function, f of x equal x squared. I'm going to start with the translation. K unit up or down. In this case, you're going to see that if you add a constant to your function, to your parent function, the new graph is going to be a translation k unit up or down depending on k, if it is plus or minus. Here are the values of k. At this position, the k is 0. Okay, so if I increase the value of k, such like k equals 1, the function is x squared plus 1. You can see it here, g of x equals x plus 1. What happened? The graph of the parent function was shifted up 1 unit. Okay, so this is translation 1 unit up, vertical translation 1 unit up. We can change k to more positive value, like here, 2 units up. Okay, so the function is x squared plus 2. So the graph of this function is the translation of the graph of the parent function x squared 2 units up, and so on. I can keep going up, as you can see, and this is x squared plus 3.1. Can have plus 3 to make it look like this. X squared plus 3, that's your function. That's when k equals 3. So for k positive, the graph of this function is k units up, translation of the parent function f of x equals x squared, k units up indicates 3 units up. Now let's go and see when k is negative. So when k is negative, like negative 1, as you can see here, now the value of k is negative 1. The new function is x squared minus 1, which shows here g of x equals x squared minus 1. This is a vertical shift 1 unit down, or a translation, vertical translation 1 unit down of the parent function, and so on. You can go down to negative 2, to negative 3. This is, we call it a vertical translation, up and down, depending on k, plus or minus. So if k is plus, it's going up. If k is minus, it's going down. Now I'm going to change the function. Okay, from x squared to x cubed. Okay, that's my function, the parent function f of x equals x cubed. And also I changed the transformation applied on this function. It has to be x cubed. Okay, here we are. Same, if I change the values of k, I can see that there is a shift up or a shift down depending on the value of k, positive or negative. Okay, for example, here this is x cubed plus 2. Okay, so this function, it shows here, this is f of x equals x squared, and this is g of x equals x cubed plus 2, and it shows here as well, x cubed plus 2. Okay, so it's 2 units up. Okay, so the red graph is translation of the parent graph, which is this one, x cubed, 2 units up. If I add more values, let's change the k to 3, so it goes up 3 units up. The function is x cubed plus 3. This is true for any function. Let's change now the parent function and make it, for example, x only. Okay, this is a straight line, as you can see, f of x equals x. This is the parent function of any linear function. So let's change this one to parent function like this. So that's your graph. Now if I take k back to 0, okay, I get my parent function. Now let's have positive values of k. So x plus 1, for example. This is y equals x plus 1. You can see here it is gx equals x plus 1, fx equals x, and here we can see gx equals x plus k, and k equals 1, so the function is g of x equals x plus 1, and so on. If I have more values, if I increase the values, you can see that it's shifting up to the position to y-intercept at 5, which is g of x equals x plus 5. Now, if you get k negative, such as negative 1, for example, the function is x minus 1. That's shifted down 1 unit. Or we can say is translation, vertical translation, 1 unit down, and so on. Okay, now let's have a constant function. Constant function, for example, f of x equals 0. That's your function here. You can see here your function f of x equals 0 is the x-axis. The equation, the function f of x is constant, the function f is constant, so you get this one. Let's change the g of x to 0 plus k. Okay, here we are. So here, when k is negative 5, the function is g of x equals negative 5. Okay, now if I want to show the transformation up and down, here we are. When k equals 0, they overlap. It's the same function, the parent function. If I add 1, for example, I get my function here, g of x equals 1. This is 1 unit up of the parent function f of x equals 0, and so on. That's it. This is up. Okay, 4 units up, transformation 4 units up of f of x equals 0. If you get uk negative, so it's transformation down, like in this case, negative 2, that's the value of k equals negative 2, as you can see. So the new function is g of x equals negative 2. What's the relation here? This is a translation, vertical translation, 2 units down of the parent function. We can have a horizontal translation or horizontal shift to the right and to the left. I'm going to elaborate with some examples. Now I have changed my function. As you can see, g of x is x minus h all squared, and I'm not using k anymore. I use h here. The value of h is 0, so when the value of h is 0, g of x equals x squared. Okay, and they overlap, f of x and g of x, which is, as you can see on this graph, the two functions, they overlap, which is actually the parent function. Now, if I change the values of h, let's say I make h equals 1, as you can see, the graph is moving to the right. That's a right shift, 1 unit to the right. This is a horizontal translation, 1 unit to the right. And the equation g of x is on the form x minus 1 all squared. You can see it here as well. G of x equals x minus 1 all squared. So if we have x minus 1 all squared, this function, the graph of this function is a horizontal translation, 1 unit to the right. Let's add more values and see how the function moves. That's translation 2 units to the right. The equation is x minus 2 all squared. Let's go to 5. That's the maximum value I have set for my values of h. You can have any value anyway. So here it's 5 units to the right, and the equation is x minus 5 all squared. If I take h negative, then it's a shift to the left. This is h equals negative 1. The equation is x plus 1 all squared. So that's the function. So this is 1 unit to the left. Okay, let's go to negative 5. Here the function is x plus 5 all squared. And this is, this graph is the translation of the parent function 5 units to the left. I can use this for any function. For example, if I change my function, the parent function, to the cubic, okay, and I change this power to cube, Alright, so I get this, and now you can see the transformation is to the left and to the right. Okay, so if h is positive, like +1, so it's 1 unit to the right, plus 5 units to the right. You can go to -5 here, so the function is x plus 5 all cubed. This is the graph. This graph is the translation of this graph, horizontal translation on this direction, 5 units to the left. As I said before, I can apply these transformations to any function. For example, here the power is 0.5 and the function is f of x equals x power 0.5. This is a square root function, power 0.5, which is power half. It's a square root of x. Okay, this is our graph for this function. So if I add like this, I make a transformation 3 units to the right, so the function is x minus 3 all power 0.5, which is square root of x minus 3. I can do it up to any value here, and I can do it as well, transformation to the left here, so square root of x plus 1. So this graph is the transformation 1 unit to the left horizontally, and so on. So you can apply it to any function. Okay, let's do it for the absolute value function. Okay, so maybe you can just do this. That's the absolute value of x. This v shape is the graph of the parent function f of x equals the absolute value of x. So let's do the transformation now. Okay, that's the function. So if I move, so I move to the right or to the left, so transformation. Okay, as you can see, this is horizontal transformation up to 5. The function is absolute value of x minus 5. Okay, so this is the transformation, translation 5 units to the right. If I make it -5 here, so the function is f of x equals absolute g of x, absolute value of x plus 5, because minus minus becomes plus. You get to the right, that's it, to the left and to the right. Okay, now let's do a combination of the two transformations, two translations, like a few units to the right and a few units up or down. Okay, here we are. I have added the parameter k to h, so I have two parameters now. The new function is on the form absolute value of x minus h plus k, so I have two parameters here. So if I change the h, I see that I have a horizontal translation. Okay, shift to the right or to the left. Okay, let's make this 0, so you can see that the function, when k is 0, you can see that I have only a horizontal translation to the right and to the left. Okay, if I make h 0, right here is 0, and I move the k, so I can see it's up and down. Okay, but if I move both of them, let's move h to the right, 1 unit to the right, and k up. So this is your new position. The function is absolute value of x minus 1 plus 1. This minus 1 applies a translation to the left, to the right, and this plus 1 applies the translation up, 1 unit up. Let's add h, so it goes to the right 2 units, as you can see, x minus 2 units to the right, and h is 1, k is 1, that's 1 up. Okay, so let's make it 3 units up. Here we are, this is 3 units up. So this function, 2 units to the right, 3 units up. Okay, if I make the h negative, you can see here we are, we go to the left. So this function, so 5 units to the left, 3 up. Okay, you can go up left or right with the h, you can go up and down with the k. Okay, and this applies to any function. Let's change my function to the parent function x squared, and change this one as well to the parent function x minus h squared. There it is. These are my functions. Okay, so if I move the h, so it's to the right, to the left. If I move my k, it's up and down. If I move them together, so it's to the right and up, or to the left and down. Okay, so in this case, for example, here, this function, this graph is the graph of this function x plus 5 all squared plus minus 5. So plus 5. This one on the x, it's applied on the x, so it's horizontal shift to the left, 5 units to the left. Okay, this one, it's applied vertically, this one, so it's 5 units down. Let me see, so I can make it up and down, maintaining the left 5 units, so I can make it right and left, as you can see. This is a combination of two transformations. For example, this one is 5 units to the right, okay, so the function is x minus 5 all squared, so 5 units to the right and 5 units up. That's it, and you can apply this to any function.